Okay, so we are going to do these next two examples. I realized when I was working through this problem that we have not yet learned the derivative of natural log, so I'm actually going to change this problem just a little bit. So I'm going to replace this natural log with a sine, and I'll change this on the PDF, so yours should say sine. I'll do that before I upload this. Okay, so just to be clear, I'll just get rid of this. So this is going to be instead x squared minus sine of x times y cubed. Okay? And we're just going to approach this in the same way. So we start off by taking the derivative of both sides. And I do like to write this step every time just to make sure I know exactly what I'm doing. Right. Okay, so on the left-hand side, we are going to need the chain rule because we have inside of the exponent, inside of this exponential function, we have 2x plus 3y. Okay, so what we're going to do is first take the derivative of the outside function, right? So according to the chain rule, we start with the derivative of e to the x, which would just be e to the x, but we don't change the inside function. We leave that there. So it will be e to the 2x plus 3y, and that is the derivative of the outside function multiplied by the derivative of the inside function, and so the first piece is just going to be 2 because the derivative of x is 1, and then the second piece will be 3 times the derivative of y, so that will be y prime on that piece. So just so it's clear, this is the derivative of the outside function, and here's the derivative of the inside function. Right? Okay. Now we have, that's the derivative of the left-hand side, so we need to differentiate the right-hand side as well. And this first piece is just the power rule, so we just get 2x in that case. And then again, we need to use the chain rule because we have something inside of this sine function. So first, we need to take the derivative of the outside function, which is going to be cosine, right? So the derivative of sine is cosine, and we leave the inside function alone, and then we multiply that by the derivative of the inside function. Now this is a little bit complicated, so what I'm going to do is just write derivative of x y cubed and deal with that in the next step, okay? So see that we have x times y cubed, and so this is going to require the product rule, and then also the chain rule because y cubed, we have the outside function is x cubed and the inside function is y. So we'll do that in the next step. Now here, what I'm going to do is I'm going to distribute this exponential to each of these terms because I know that I'm going to want to solve for y prime, and so I'm going to need it to be separate from this 2, right? So I need to separate those, so I'm going to multiply it out, and I will get 2 times e to the 2x plus 3y plus 3 e to the 2x plus 3y times y prime. Okay? And now we just need to finish the derivative of the right-hand side. So as I said, we're using the product rule. So we'll start with the derivative of x, which is just 1 times y cubed plus x times the derivative of y cubed. So first we use the power rule. That's going to be the derivative of the outside function, so 3y squared, times the derivative of the inside function, which is y. So this will be y prime. Okay? And now we just want to simplify and solve for y prime. So again, we have y prime in one of these terms, right? It's right here. It's also here. So we're going to multiply this out so that we can get that y prime term by itself. And I'm going to go ahead and write this. We'll write cosine x times y cubed plus we'll put the constant out front, 3xy squared cosine of xy cubed times y prime. Okay, let me actually rewrite this. I want my y prime to be very obvious. So we have 3x y squared cosine of xy cubed times y prime. Okay, and then I'm going to cheat and just put quotes there. Now I want this term on the same side as this other one, so I'm going to pull that over here. And at the same time, so I'm moving through the steps a little bit faster this time, I'm going to pull this other term that doesn't involve a y prime to the other side. So I would get 3e to the 2x plus 3y times y prime minus that other term with y prime in it, so 3xy squared cosine of xy cubed times y prime. And then, so just copying these two terms, we usually put the y cubed in front, so I'll do that. Y cubed cosine of xy cubed, and then minus that term that came from the other side, so e to the 2x plus 3y. Now, let's see, we just need to factor out this y prime from both terms. So we will have the same stuff times y prime, and then, I'm going to just copy it down for the final answer. So this will be dividing by this whole thing. We'll get 2x minus y cubed cosine of xy cubed minus 2e to the 2x plus 3y over 3e to the 2x plus 3y minus 3xy squared cosine of xy cubed, right? So that is our final answer. Even though it looks very messy, it is perfectly fine. That is the answer there. Okay. So I think that this difficulty is about as bad as any problem that you're going to see in this section. So it involved using the chain rule, a chain rule, and a product rule inside of it, and then solving for y prime. So really, if you just break it down, it's really just two steps, and the second step is it's just algebra, right? It's just solving for y prime. So I would just say try to be very careful when you're solving these, because it is easy to make algebra mistakes. So just go slowly and make sure you're checking your work as you go. Okay, so the last problem is a little bit different. So this is one of these inverse trig functions, and I just want to do it because it's a useful one, and so that you know what the derivative of inverse tangent is. So remember, we just use the fact, so this is very similar to how we did the derivative of inverse sine. We did inverse sine, right? So y is equal to tangent, or inverse tangent of x if and only if x is equal to tangent of y. And then now we have a relation, an equation that we can use implicit differentiation on, right? So using implicit differentiation just means I take the derivative of both sides and I assume that y is a function of x, right? So on this side, the derivative of x is just 1, so we get 1. And then on the other side, we have y inside of tangent, so we use the chain rule, right? So the derivative of the outside function is the derivative of tangent, which is secant squared of y, and then we multiply by the derivative of the inside function, which is just y prime, right? Okay, so that means that we get 1 over secant squared of y, right? And remember that, yeah, that's right. Remember that we like to have the answer in terms of x because we do know that this is a function of x. And so again, we can use our trig identities to actually get this in a form where it will be some function of x. And so what we can do in this case is we don't have to worry about the domain in this case, luckily. And what we just do is starting from our, so this is what I would say is the most important trig identity. We can turn this into something that involves secant and tangent by dividing the entire equation by cosine squared of y. And so notice that if you do that, so if I divide everything by cosine squared y, what I will get, splitting this into two different fractions, I would get cosine squared y over cosine squared y, right? And then sine squared y over cosine squared y, and then 1 over cosine squared y. And so this first thing, this is just equal to 1. And then remember that tangent is equal to sine over cosine, so we can rewrite this piece as tangent squared of y. And then this last one, the definition of secant, or one way you can define secant is 1 over cosine, so this is secant squared of y. Okay. So what we get is now that secant squared y is equal to 1 plus tangent y, right? So what I'm going to do is I'm going to replace this secant squared that I have in my derivative with 1 plus tangent squared y. And the reason I want to do that is because I know that x is equal to tangent of y. So I can then, after I replace this using my trig identity, I can replace that tangent of y with just x. And so I will get 1 plus, or 1 over 1 plus x squared. And that is the derivative of inverse tangent, right? So just to make a note about this, so the inverse trig functions that we've found so far are so inverse sine, the derivative of that is going to be 1 over the square root of 1 minus x squared. We had inverse cosine, which was on the in-class work, and so you should double check that this is what you got, but this should be negative 1 over 1 minus x squared, right? And then we've just done tangent. And that is 1 over 1 plus x squared. Okay. And so that is all for this portion. So make sure you do the comprehension check question.